Welcome, my name is Brad Nickerson, and I'm the president of the Jemseg Grand Lake Watershed Association. To let you know, this webinar is being recorded as a video, but no video or audio of attendees is being recorded. Only the host, myself, and the speaker, Jasmin Boisvert, are being recorded. Our watershed covers 3,950 square kilometers, which is more than 5% of the area of the province of New Brunswick. And Grand Lake at 171 square kilometers is the largest freshwater lake in the Maritimes. If you are not already a member of our association, we invite you to join. We'd love to have you as a member. Memberships cost $10 per year and support our activities, including the organization and hosting of this webinar. Contact us at our email address that you can see there. I need to move this way. jemseggrandlakewatershed@gmail.com, or you can use the membership application forms that you can see linked there on the, you can't click them unfortunately, but they will appear when this webinar goes up as a video on our YouTube channel, so you can click them at that time. Right, we welcome your questions. Please use the Q&A or Q&A question and answer box or the chat window to ask questions. Jasmin Boisvert will make his presentation, and then he's going to answer some questions that have already been posed by people prior to the start of this webinar. Some people were very keen and sent in questions in advance. And if time remains after he answers those questions, then he will answer additional questions that you've typed into the chat or Q&A windows. Okay, so this webinar this evening is limited to 1 hour. There's a time limit of 1 hour on this webinar. So we're hoping, we're planning to end at 8 p.m. or very shortly thereafter. All right, now we're gonna have a quick live poll. I'm gonna turn my video off just for a moment and come up with something called a live poll. And it's gonna ask a question on your screen. And as soon as you see it, there will be 5 possible answers and you can click one of them. All right, so I'm going to launch the poll at the moment. Now, if you would just choose one of those options there to the following question. The question says, what do you think was the primary cause of the 2018 flood in the lower Wəlastəkw or St. John River? And answer 1 is a combination of rain and rapid snowmelt in northern Maine and New Brunswick. Answer 2, climate change causing more frequent and intense rain events in addition to sea level rise. And answer 3 is opening up the Mactaquac Dam gates to lower water levels behind the dam. Number 4, answer 4 is too much forestry clear cutting in northern Maine and New Brunswick. And answer 5 is I don't know. That's what I'm here to learn. And I see we have 87 people have answered so far of 137 attendees. I'll just wait a few more seconds. We're up to 107, 110. All right. And if you wouldn't mind just clicking one of those buttons, what that will do is give Jasmin a good idea of what the audience background is and what their thinking is on what caused the 2018 flood in New Brunswick. All right, we're up to 123. I'm going to end the poll in just a moment here. It's an anonymous poll, yes. Nobody will know who voted for what. So feel free to vote if you haven't already. No one is going to come after you if you say you don't know and call you that well, man, you're living in New Brunswick, you should know. So, all right, I'm going to end the poll now, and hopefully everybody can see the results. And I'm just going to read them out briefly. The top 2 responses at 56%, 56 answers, 44% think that a combination of rain and rapid snowmelt in northern New Brunswick and in Maine was the primary cause. The next highest answer is 17%, I don't know. The next highest one after that is opening up the Mactaquac Dam gates to lower the water levels behind the dam. And then the fourth one, 14% answered too much forestry clear cutting. So there's a clear winner there, that rain and rapid snowmelt in northern Maine and New Brunswick was the primary cause. And sorry, I didn't press the share. Share the results button was not pressed by the host. I apologize for that, but you should be able to see it now. Okay, so I'm going to read a little bit about Jasmin Boisvert. Jasmin is a water resources specialist with the New Brunswick Department of Environment and Local Government. And since joining the department in 2016, he has primarily been working on the province's flood hazard mapping initiatives, updating the province's flood forecasting and modeling tools, and providing advice and expertise related to water resources in a variety of other projects and initiatives in the province. And in the past, Jasmin has worked for the Université de Moncton, primarily working on research projects regarding hydrological modeling, statistical hydrology, and water availability. Jasmin has a bachelor's degree in civil engineering and a master's degree in applied sciences focused on hydrological modeling, both from the Université de Moncton. Okay, I'm going to turn it over. I'm going to stop sharing the poll. I'm going to turn it over to Jasmin now. So Jasmin, if you can take it away, that would be great. And you'll have to share your screen. I just want to make sure you can share your screen. Here we go. Yes, I just enabled that.
Oh, thank you very much. That's what I was waiting for. So there we go. Can you see my screen?
I can. You should make it full screen, but yes, it's definitely there.
All right. What can you see now?
I can see the whole PowerPoint interface.
How's that?
Still not showing full screen.
Okay. There's several screens going on here, so that's
always a challenge.
Always a challenge to figure out what.
Yeah, and here. We need to make it full screen. Here we go. I think you'll have it now. Oh,
no,
come up, did it?
That's interesting.
I think you might have to stop screen sharing and then make it full screen and then share your screen.
Let's try that.
I'm hoping that will work. Well, it worked 2 days ago, so it should work fine now as well. There we go. Perfect.
All better?
Yes, it is.
You can see the right screen, full screen and everything?
Yes, full screen is there. So it's all yours, Jasmin.
All right, well, thank you very much, Brad, and I appreciate the introduction, and thank you everybody for joining us here this evening, and I hope that this presentation will be informative, and thank you for your attention. So I'll start off. My name is Jasmin Boisvert, so I'm Water Resources Specialist with Department of Environment and Local Government. So I do work a lot in flood forecasting and flood mapping and various related fields. So I'm happy to give this presentation, and I hope I can be of use. So I'd like to start off with this nice picture here of Sussex in 2014. It's a very classic Canadian picture with Tim Hortons being flooded. It's certainly very, very iconic. Today, my presentation, I'll start by talking a little bit about flooding in New Brunswick in general and the different causes and the different types of flooding. Then I'll move specifically into inland flooding and the different causes of that. And then I will spend the bulk of my presentation talking about the 2018 spring flooding in general. And I'll compare just briefly the 2019 spring flooding versus the 2018 event. And then afterwards, we can have a little Q&A or discussion, if you will. The first thing, flooding in New Brunswick, locations. Well, the short answer is pretty much everywhere. Along the coast, you often have storm surge events, such as when a hurricane or a tropical storm rolls around. And if you combine one of those with high tide, you will often see coastal flooding effects that you might see in Shediac, for example, or along the Acadian Peninsula. And that can have certainly some fairly steep impacts. Coastal erosion is also another issue with that kind of event. We also have heavy rain events, such as also tropical storm or hurricanes or thunder showers and that sort of event. Those are typically more common along the Fundy coast where rain is a little heavier. And those kinds of events can often impact municipal systems or smaller tributaries and that sort of thing. You also have ice jam flooding, which is more common in the center part of the province along the St. John River and Perth Andover kind of area, on the Tobic River, as well as along the Miramichi and other areas of the province as well, but less frequently. We also have the spring freshet flooding, or the snowmelt driven flooding that we often see in the lower part of the St. John River Basin, and that we saw recently in 2018 and 2019. In terms of damages that can be caused by flooding, we see often charts like this to say that the trend is going up. And in this case, you can see that it starts off pretty mundane here. There's a few years here where there's particular events that cause a lot of damage, like in 1932, there was a fairly large event. And then in 1973, there was also a fairly large event. 2008 was also another large event, and 2012 in Perth Andover. And so you can see there's quite a bit of damage. If you look at this decade here, the 2003 to 2012, I mean, we're looking at upwards of $130 million in the province. And so it's not an insignificant amount of money. And if you were to add the extra 10 years after that, we don't have 10 years after that, but if you were to look at 2013 on, you would have two particular events in there, of course, which would be the 2018 and the 2019 flooding events. And the 2018 flood event by itself was estimated so far to be about around $80 million worth of damage. So just that one particular event is already getting you higher than most of these other decades. And then you add 2019 on top of that, and it certainly starts to add up really fast. So it's certainly starting to cost a lot of money for flood damages that could otherwise be money that could otherwise be used elsewhere. And so it's certainly a trend that needs to be considered, and it's certainly something that I'm sure it would be good to look at as to how we can mitigate this or prevent this from happening in the future. And flooding it's not new in the province. It's not just this past decade or these past even few decades that it's been going on. The Department of Environment and Local Government has actually a flood history database. And it's fairly easy to find. If you just Google New Brunswick flood history database, then you'll easily be able to find it. And you can see the first entry here. I like to point this one out because it's 1696. I mean, it's 300 years ago. And it says a late and very high freshet caused late planting and crop failures at Jemseg. And so this problem of flooding is certainly not new. This has been happening for hundreds of years. And it still will continue to go on for hundreds of years after this, for sure. But I particularly like this entry as well because the second entry, which is 5 years later, it says, well, the French settlement at Jemseg was abandoned and they moved to Nova Scotia. So somebody decided that, 300 years ago that Jemseg was flooding and they got tired of it. And so they decided to move somewhere else. And so flooding is not a new problem in New Brunswick. It's certainly been ongoing for a long time. And the interesting thing about this flood history database is that you can search for particular events that you would like to see, and you can just do a general search to see what events there have been in your area. If you want to look at a place, you can see different causes such as heavy rain or ice jamming. And oftentimes there's a lot of detailed entry to describe what happened in particular. So I just pulled up an example here, which is Tropical Storm Hannah in September of 2008. And you can see a list of the affected places. So Moncton, St. John, Sussex, Grand Bay, Westfield, all these areas were affected. And it says causes of heavy rain, and it even estimates an approximate amount of damage. So $16 million for this particular event, which is a fairly significant amount. And it provides a description of that particular event. So heavy rainfall from Tropical Storm Hannah caused localized flooding in the southern half of New Brunswick. And there was flooding in coastal areas as well. And oftentimes it will describe how much rain there was. If you could see at the bottom of the page there, it says Environment Canada reported 141 millimeters at Point Lepreau. So certainly a significant amount of rain. And sometimes there's also pictures that are included as well. And so it's a very good source of information, and I encourage people to use it and to look at it when they have the time. It's certainly a good thing to know if there's been flooding in your area in the past. I mean, I know most of you are probably from the Jemseg Grand Lake area, so this is no surprise. So I'll talk a little bit about the different causes of inland flooding. I have another picture here of Sussex in 2014, not trying to pick on them or anything, but it was a fairly recent event, and there's a lot of good pictures of what can happen when flooding does occur. So one cause of flooding that you can sometimes get are major storms. Tropical Storm Hannah was an example there that I previously showed in the flood history database. This is Hurricane Arthur in 2014 as well, and it just shows the track of the hurricane. But something like this can drop 100 or more millimeters of rain in a day or two over a very widespread area. And that can cause a lot of issues locally in drainage systems or smaller tributaries, but it can also cause a lot of issues for larger rivers as well when a large amount of rain falls over a widespread area. We can also get more localized storms. So this is just an example, I think from August 17th, 18th, probably 2019, I think it would have been. And you can see on this map here, there's a nice big bullseye of red. And the highest amount here you can see is 129 millimeters of rain over a day. And that kind of event is typically more problematic for smaller rivers or tributaries. So in this particular case where it would be falling over Sussex, you might see a lot more impacts on the Kennebecasis, but more likely you might see more impacts on something like Trout Creek. Or you would see, if this were to fall over something like St. John, you would see a lot of the municipal infrastructure, like the sewer systems, start to become overwhelmed and might see some flooding on the streets and that kind of thing. And this kind of storm is particularly more associated, you might think of thunder showers where a lot of rain falls very intensely for an hour or even less. And so you might get a lot of rain in a very small amount of time, and that can really overwhelm some local systems. The other particular event that we can have in some areas of the province, not all, but most areas of the province, you can have ice jamming. So ice jamming is when there is ice cover over the winter on the river, and during times of either high flow or warmer temperatures, that ice starts to break up. And when that ice starts to break up, it starts to move down the river. And sometimes it can't move down the river because it gets stuck on either a more intact ice sheet, and so it can't move downstream anymore. It might get caught on some islands in the middle of the river. It might get caught on just a bend in the river or a change in slope in the river, or it might just there might just be too much ice that it can't pass all through a particular section of the river channel. And so what happens in this case is that the ice starts to accumulate. And when the ice starts to accumulate, water can't pass through as efficiently as it should. And so you often get water levels rising rapidly because it essentially acts as a partial dam in the river. And these can form very, very quickly. And so this kind of flooding event is typically very localized in a particular area, but they can also be very dangerous because an ice jam can form, and then within a matter of minutes, let alone hours, let alone minutes, the water level can rise several feet. And so if you're not aware that this can happen and you're not paying attention, then this can happen very quickly, and then there can be very, very sudden impacts in just a few minutes time, a few hours time. And so a particular event that a lot of people would remember would be the Perth Andover ice jamming in 2012, which is their record high event. And a lot of people that were there would say that they could even see and hear the ice chunks would be hitting off the bottom of the bridge. And so it wouldn't have taken much more for that, just maybe another foot or two of water for that ice to be enough to accumulate and hit off the bridge and then jam under the bridge, in which case it could have very well lost the bridge. And that happens fairly often. We see that ice jamming starts to accumulate on the piers or starts hitting the bottom part of the bridge, and then it starts to accumulate, and there's a very large amount of force on that bridge, and sometimes it can crack and can move, and sometimes you lose the bridge. And so this can be a very impactful form of flooding. So the one we are going to talk about mostly today, it would be the spring freshet kind of flooding, which is, as the name suggests, typically happens in the spring. And so that's when the long winter that we have here, there's a lot of snow that accumulates over time. And so over the few months of winter, there's often a lot of snow sitting up across the province. And at one point or another, when temperatures start to rise, that snow does begin to melt. And oftentimes it can melt too quickly and there can be rain on top of that. And then when that happens, there becomes a lot of water that comes down all at once. And that's where you get the spring freshet flooding. So to talk a little bit more about the spring freshet flooding, I'll take you through a little bit of the 2018 flood in particular and how that came to pass. But first, I want to talk a little bit about the St. John River Basin. So the St. John River Basin it's international because about 37% of the drainage area is actually in northern Maine. About 17% of the drainage area, 37% and 13% of the drainage area is actually in Quebec as well, so it's interprovincial. The St. John River itself does not cross into Quebec, but a lot of the tributaries and the headwaters do start there. In total, it's about 55,000 square kilometers. About 39 to 40,000 of that is above the Mactaquac Dam. Another important thing to note is that in the northern Maine and northern New Brunswick part of the basin, it's more of a hill and mountainous terrain at elevation. And so there's more characterized by steeper slopes, so faster drainage, and also with colder temperatures as well. So oftentimes we'll be here in Fredericton or in Jemseg or in St. John, and we might be getting snow melt and we might not have any snow on the ground anymore, but up north it's still several degrees colder, and so it can still be winter up there while we are experiencing spring down here. And so that's very important to keep in mind. Another thing to point out would be that once you get past the Mactaquac Dam, that lower stretch of the river is actually very, very flat. There's almost no slope to the river. And so the difference in elevation between the river at Fredericton and at St. John is very, very small. The area around the river as well is a characteristic floodplain, whereas you can see in Majorville, for example, it is also very flat and not very high up from the river. So those things combined, along with the rather large lakes that we have, such as Grand Lake and Maquapit and French Lake that are in that area, all of that acts as storage for the river. And so that's very important to remember, that these areas are very flat and they are essentially what is considered a floodplain. The other interesting characteristic, which is fairly unique, is that the St. John River and all its 55,000 square kilometers all drain through to Reversing Falls and then into the Bay of Fundy. And this is interesting because that 55,000 square kilometers, and where this river, the St. John River, is oftentimes even wider than a kilometer, all has to go through this one narrow opening in St. John. And so this narrow opening may be 150 to 200 meters wide. And on the other side of that opening is the Bay of Fundy, which has the highest tides in the world. So those two things added together means that it acts as a very important feature and a very important restriction in the outflow of the river. And so this causes some issues when the water levels start to rise. And so this is just a picture of the Reversing Falls in 2018. So you can see that typically the river right now is actually very high, but the other side, on the other side of the bridge there in the Bay of Fundy, or closer to the Bay of Fundy, is also very high. So interestingly enough, in 2018, when the water level was high enough, the Reversing Falls did not reverse. At high tide, it still wasn't enough to overtake the river and to make flow go up the stream. The river was so high that it just kept going. Of course, it still restricts the flow outward, and at low tide, it certainly helps to get more water out, but it's not certainly an issue to be considered when talking about flooding in the St. John River. So now to talk a little bit about, we know what happened in 2018, we know the result, but how did we get there from where we were in March? So to start, I just want to talk a little bit about snow surveys that we do. So the Department of Environment partners with NB Power, some of the watershed groups around the province as well, the province of Quebec, their Department of Environment, as well as the USGS, so the United States Geological Service in Maine. And we partner with all of them and we collect this data. People go out and take core samples of the snow and they measure the weight and they measure the depth, and we compile all this data and we put out a map that says how much snow is across the province. So if you look at this particular map in mid-March, this map shows percent of normal. So it compares how much snow was on the ground in mid-March in 2018 compared to the long-term average. So if you look at these blue colors, the majority of the province is at about 100 to 125% of normal, which isn't significantly different than normal. I mean, we would not even call that above average. We would just say that is a normal range, measurement error even. It's just, it's a perfectly normal amount of snow. It's nothing concerning. It's just normal. I do want to point out that when we do these snow surveys, we do measure snow depth, but we also measure snow water equivalent. And that's what's more important to us, because not all snow is equal. You can have the nice, light, fluffy snow, but you can also have the thick, wet, heavy snow. And so it's important to know how much water is in that snow. So we often talk about snow water equivalent, which means if I were to measure 100 millimeters of snow water equivalent in the snowpack, then that would mean if all of that snow were to melt, then 100 millimeters, it would be the equivalent to 100 millimeters of rain falling. And so it's much more important to us to know what the snow water equivalent is, because we want to know when it melts, how much water can we expect to come down the river. So what normally happens in March and in April is that normally we start to see some warmer temperatures, sometimes in the positives, might fall back in the negatives at night, but oftentimes you'll get, say, a plus 10 degrees in the day and maybe a -5 at night. And so you start to see a little bit of snow melt, a very gradual snow melt. And that's what we look for, that's what we hope for. But what did happen though is on April 3rd, for example, we had record-setting low temperatures across Northeast New Brunswick. April 4th, we had 20 to 30 centimeters snowfall reported and even 41 centimeters in Doyleville. You add that April 9th and 11th and 15th, there was record-setting low temperatures again across New Brunswick, with Edmundston reaching -20.6 degrees Celsius on the 10th. And that's, I mean, it's mid-April and it's -20. That's not normal. That is very, very cold. April 16th to 18th, several hours of intermittent freezing rain and ice pellets. So not only did we not melt snow like we normally would, we were adding on top of the snowpack. We were adding 20, 30 centimeters, freezing rain just sits on top of it. So we were adding more and more water to the pile. So now if you look at the mid-April snow survey, so a month later, it tells a very different story. Now you see a lot more darker blues and you see a lot of purple as well. So the darker blues, you're looking at 150% of normal. And in the purples and pinks, you're looking at over 200% of normal. So that's significantly above what you would want to see. It's significantly above the long-term average. In terms of what that actually means in quantity, if you look at this mid-April snow survey and the snow water equivalent, you're looking at upwards of 250 millimeters of water in parts of the basin. And that's just water that's waiting to sit there to melt and just to come down the river at some point. So now you're starting to get a little bit more concerned because it's mid-April and there's still 250 millimeters of water waiting there. But this can still go one of two ways. We can still get that gradual warm up, and this can still melt gradually over the next 3 to 4 weeks if we're lucky. Unfortunately, the second way it can go is that you can get rain on top of that, or you can get a big heat wave that melts it all very rapidly. And unfortunately, that is what we got. And so we didn't get the gradual melt that we were looking for. Instead, if you look at this, April 24th is the first day that we had 20 degrees Celsius or warmer for southern and inland New Brunswick. And so you go from a winter condition where everything is still frozen to 20 degrees essentially in less than a week's time. So these graphs here are actually created from our American partners down in Maine, and it's the National Weather Service. And so they create this product where they estimate how much snow is melting across their country, but they also have extended that into southern Canada, and so New Brunswick was included in that. And so if you look at this, this is how much snow melted in 24 hours. The graph on the left, or the image on the left, is April 25th. So April 25th, you're looking at about 30 millimeters of snow water equivalent that melted. If you look at the next day, April 26th, this is all very dark red. It's the greater than 50 millimeters of snow water equivalent melting in a day. It's literally off the charts. So we don't actually know how much snow is melting, but it's estimated at over 50. So already in 2 days, you're looking at it's as if 80 millimeters of rain had fallen across the province. But it's not stopping there either. So the next 24 hours on April 27th, you're looking at another 35 to 50. And then the next day you're adding another 20 to 25, and then it's starting to slow down a little bit. But all things said and done, over those 4 days, you're already looking at about 170 to 180 millimeters of water coming down. So you can imagine that 180 millimeters of rain would cause quite a significant amount of flow. So all this is well and good. It's a lot of water coming down the river. So what do you not want on top of that? What you don't want on top of the snowmelt is a rain event. And unfortunately, that is what we've got. So on April 26th and 27th, we had a general rain event across the province, and generally about 20 to 30 millimeters of rain fell across the province. And in that key area in the northwest, where there's a large portion of the St. John River Basin, there was about 35 to 45 millimeters. So now on top of this 170, 180 millimeters of snow melt, we also have another 35 to 40 millimeters of rain. And so you put those two together, you are going to get a lot of water coming down this river in a very short amount of time. So the result of that, what does it look like? Well, this is the hydrograph at Fredericton. So on the left, you see the primary water level in meters and the date and time. So this covers a few months of time. And the red bar across it is Fredericton's flood stage, which is at 6.5 meters. And during this event, we actually spent about 14 days above this flood stage, which is an incredible amount of time. Typically, you don't see that. You see a quick rise, and then it starts to peak, and then it comes back down. You don't typically see this nice, long, drawn-out event for 14 days. It's just a very long amount of time. Another thing to point out here is how quickly the water rose. The water rose about 3 meters in 24 hours. That's just unheard of for us. We would have never seen something go from 5.5 meters to over 8 in 24 hours. That's the kind of thing where you go to sleep at night and then you wake up and it's a completely different landscape. We also talk internally all the time about this. This is just not something that could have been predicted. If our models would have came up with this prediction, we would have said the models were wrong because it's not possible. But here we are, and it happened. And so all this snow melt and this rain on top of it really just made the water come rushing down this river and had quite the significant impacts. Another thing you can see here, I think you can see my mouse, is that the water went up really quickly, and then this is where the snow is melting because we had very warm temperatures for the next 2 weeks and a little bit of rain. There's still more snow and rain. And then here's where we run out of snow. At this point, there's just no more snow to melt. And so that's when you see the water start to drop. So the result of that, I just have a few pictures I want to show. This is downtown Fredericton. So you can see a lot of the streets downtown are flooded as well. And you can see some of the storm sewers up here. The water came up through the catch basins on the street. And you can see some general impacts. If you look at Majorville area, I mean, there's water as far as the eye can see. The water just extends for hundreds of meters past its banks. There is a road in here somewhere, but you can't see it because it's covered in so much water. And so there's quite a significant impacts. And this is the Burton Bridge. You can see a lot of people try to park their cars on the on-ramps and off-ramps in an attempt to try to keep them dry. But again, there's just so much water, you can't even really tell where the river stops and the land starts. In Grand Lake, a lot of you might recognize this area, so you can see that this particular road is completely inundated, and most of this island as well. And so there's just a few buildings in the middle that are okay. Same with this particular stretch of land. You can see most of this is inundated, and a lot of the cottages and the buildings here are as well. Yeah, so I mean, you can see there's a lot of inundation there and a lot of damage. If you look at Jemseg, the Trans-Canada Highway, this is all you can see of it. So you can just barely see the two strips of road. And if you were to zoom in a little bit, you would see that most of at least one whole lane is covered, and most of the second lane is also covered here. This is another stretch of it. You can maybe see a little bit better here. A lot of it is covered over here. So you can imagine that it's a significant amount of water just floating around, and there's quite a bit of impacts. And then you can also remember, perhaps you can remember, at one point or another, wind was also a significant factor in this. And so here, when you have wind, this looks like a particularly calm day. You don't see any particular waves, but when there are waves that are crashing into this Trans-Canada Highway, it's not hard to imagine that there would be a significant damage on the shoulder of those highways, and the structural integrity of it might be compromised. And so you certainly understand why it was closed, because the water is just very close to overtopping it, and waves would certainly have overtopped it and caused perhaps damage underneath to the structure of the highway. So I'll talk just briefly about the 2019 flooding. I'm not going to go into too much detail because a lot of the factors were very, very similar to what happened in 2018. The snowpack was also about average when you look at it from mid-March. There was nothing special about it. It was just a regular year of snow. The same problem was also there in end of March and early April, is that there was almost no melt prior to the big flooding and the first big melting event. The bigger difference, I would say, between the 2019 flood and the 2018 is we probably got more rain during that spring freshet in 2019 than we did in 2018. And rain continued to fall, maybe not in heavy amounts, but when you're already flooded, when you're adding 5 to 10 millimeters every day for a week, it does add up. And so if you look at the hydrographs for the two, the blue line is the 2018 flood, and it's the same line that I showed previously. And the 2019 flood is the orange line. Now, the 2019 flood did happen a week or two before the 2018 flood did, but I just shifted it over a little bit just to make the peaks align so you can kind of see the different timings here. So for example, in 2019, there was a small patch of melt that happened here, not very significant, and it clearly was not sustained because the water level dropped after that. So there was just a quick burst of melt, but nothing really enough to get rid of a lot of snow. At the same time, the rise wasn't quite as quickly because there was a few days where the water did start going up before this main rise. But at the same time, there was a very quick rise when the water did finally come, when the main spring freshet did come. It did rise up fairly quickly, and that is in large part due to the snow melt and the rain. One of the big differences you'll find between the 2019 and the 2018 flood is that in 2018, when it turned warm, it stayed warm. And so we melted all of our snow until it was gone, and then the water levels dropped very quickly. In 2019, we didn't have very sustained high temperatures, and so the snow melted more gradually. And so we had a big rain and some snow melt, and then it cooled down. And so the water level started to drop, and the snow was melting much more gradually. And so that's what you see here, and why this is not as steep, and it continues to have more water, more flow at the tail end, is because the snow kept melting over a few weeks as opposed to just melting all in 1 or 2 weeks. It kept melting after the fact. And so that is my presentation on the 2018 and the 2019 flooding events, as well as flooding generally in New Brunswick. So I believe we have some questions. Brad, I will turn it over to you if you have any comments before I start answering some questions.
Yes, thank you, Jasmin. I'll keep you as the only presenter at this point, but I just mentioned Jasmin is going to answer some questions that attendees submitted before the webinar, some of the keeners in the group. And Jasmin, if I could, would you mind reading the question before answering it so everyone will know what the question was?
Sure, that's no problem. There were several questions that were along the same themes, so I might not read the exact question because I did group some of them together. I hope that's okay.
No problem.
So for the first question, somebody asked, during this session, I am interested to learn what, if any, effect Wətəqwə may have on the flooding of Grand Lake or the St. John River in general. And I hear many assumptions that water management at the dam is the cause of flooding, but have not been able to find any evidence of that being the case. So the answer to that, NB Power, first of all, is a very important part of the River Watch program that does the flood forecasting. And they are very forthcoming with data. They provide help in any way they possibly can. And their number one concern realistically is the public safety. They also have very good information on their website about the dam and how it operates. So I encourage you to go visit that website and ask them any questions if you want to. In terms of whether or not the dam has any impact on flooding, is essentially it does not, simply because the Wətəqwə Dam is a run-of-the-river dam. And so while the head pond might look large or impressive, it doesn't have any significant storage capacity. You could completely empty out the whole head pond, and if you were to close the gates, it would fill up in a matter of hours. And so there's not a whole lot of water, or a whole lot of storage capacity behind there when you consider just how much water is coming down the river during a spring freshet event like we had in 2018. The dam has very strict operating guidelines. And so the point of those are essentially to mimic the natural flow of the river as if the dam weren't even there. And so they really have almost no control over how much water they hold back or how much water they let go. When it's flooding, when there's such high flows like we had, they're just letting everything that's coming in go out. That's all they can do. And if you were to close the gates at the dam at high flows to try to alleviate flooding downstream, it would cause backwater effects. And so not only would you be flooding downstream, but upstream in communities like Woodstock would also see unnecessary flooding, because then you would just be flooding both people to the same extent. As it wouldn't help downstream, and you'd just be making things worse upstream. It would also be very dangerous to try to close the gates and restrict the water flow going through them, simply because it can get out of hand really quickly. And so if you start closing the gates and start playing with that, then water levels behind the dam can rise, and you can start looking at the failure of the dam. And so you could easily get a breach, and that would be fairly catastrophic if the dam overtopped. So that's the answer to that question. We can certainly follow up with that later, but I would like to get to some of these other questions. So another question that we had, would a lack of proper maintenance on the drainage culverts under the highway at the Grand Lake Meadows slow down drainage and contribute to the flooding duration? Or would the geographical changes created by the new highway exacerbate the flooding? So that's a good question. I don't work for DTI or the MRDC, which is the company that takes care of the highway and the culverts under the highway. So I can't really talk about what kind of maintenance it has. But given the scale of the watershed and just the sheer amount of water that's flowing down this river, a few culverts don't really have much of an impact on flooding, whether they're blocked or not. So at such high water levels, the St. John River and the Jemseg River and Grand Lake and all those other lakes that are around it, they're essentially blended together. So a few culverts isn't really what's making the difference. Essentially, even if those culverts were bigger, there was more culverts, they weren't plugged up, the reversing falls is also the dominant factor for backwater. So even if you could get more water out of Grand Lake, it would just have nowhere to go. So you could create as much flow or as much room to get out of Grand Lake and through the Jemseg River or past the Trans-Canada. But at that point, there's just so much water everywhere that there's just nowhere for it to go. So that's that question. Along that same line of thought, there's a question about when was the last time the Jemseg channel leading into Grand Lake was dredged, and would sediment buildup in the channel contribute to the duration of the flooding? There's a very similar answer to that question, because I'm assuming that the idea behind dredging here would be to create a wider channel and get more water out of Grand Lake and downstream. But the same answer applies, is that there's really just nowhere for the water to go. So even if Jemseg channel was twice as wide, 3 times as wide, there would be no water flowing out of it because there's just so much water backed up all the way from St. John and Reversing Falls that it just wouldn't make any difference. Dredging in general also is just not an effective solution to flooding. It's very short term, and even if the channel has more capacity, typically downstream or upstream doesn't, and so it doesn't really have much of an effect. A similar conversation about dredging was also had recently in early December regarding Trout Creek in the Sussex area, because in early December there was a big rain event and a lot of the town did have a flood. The Kennebecasis Watershed Restoration Committee, the KWRC, posted very good information about dredging and the ineffectiveness of it on their website. So if you have further questions or you're looking for more information, I'd highly recommend going to their website and taking a look at that. Another question that we got was, is there a correlation between the timing of high water, full moon in the Bay of Fundy and peak floods higher up the St. John River? For example, is it possible to say that peak flooding up the river will be a certain number of days after a full moon? So we get questions similar to this a lot as well, because the tidal influence is certainly there. But realistically, it's not necessarily how high the tide is that is the issue. It's the fact that there is a high tide and a low tide. So it's not necessarily that the high tide is the highest tide of the year that would be a problem. Just generally the fact that there's high tide and low tide causes a lot of issues. Because at high tide, much less of the water can come out of the reversing falls. At low tide, a lot more can come out, but at the end of the day, it still causes a backup effect. However, in terms of the timing of flooding events, it really doesn't have a whole lot to do with the full moon or the tidal cycle. Realistically, if we had gotten the snow melt several days earlier, along with the rain event several days earlier, then the flooding would have been that same amount of days earlier. It really wouldn't have mattered if the full moon was that particular day or not. It really is day-to-day weather, how much rain and how much snowmelt we're getting. That's what determines how high the water is going to be and when.
Jasmin,
yes.
can I interrupt you for a second? Your camera seems to be cutting the top of your head off the way it's oriented.
Oh.
Would you mind just pulling it down a little bit? Yeah, that just gives
How's that?
better. That's perfect. Yes, thank you.
Appreciate that. I can't really see myself. I have 3 screens open, but not one of them shows me.
Okay,
So,
that's great.
All right, better?
Thank you, yes.
So another question that we get is regarding elevation buildings for safety and where do we find suggestions? So I took that as saying, well, if you wanted to raise your cottage or your house or protect it in some way, where could we find some information? And so one good source of information that we do have on the Department of Environment website is there is a flood proofing document. And so that has suggestions as to how you could potentially protect your house or retrofit your house to make it more resilient to flooding. Like, for example, the cottage that is on stilts here in this image that I have up. Another source of information could be the regional service commissions. A lot of them have their own regulations and guidelines regarding what to build to in terms of elevations and flooding. And so that could be worth a check as well. Another point that I would like to make is that the Department of Environment is working on flood mapping. And so that would essentially map out what you can expect in terms of future flooding and what that might look like and how frequent that might be. So that's not quite done yet, but once it is complete, it could help inform decision making on the subject. So it could give you a better idea what kind of elevations you can expect. In the meantime, I don't have anything very concrete for you from us, but if you have any questions in particular about your property or you want some guidance, please feel free to reach out to me or the department, and we'd be happy to help in any way we can. I'm missing, so another question. What time is it now? All right, another question is, given the increased frequency of high floods in the past 10 years, is there a reasonably robust view of why this increased frequency is occurring? Should we expect the increased frequency to be the new normal? What would the chances of a 2018 flooding of level or greater will happen again? The answer to that, unfortunately, is flooding is a randomly occurring event. We could have this kind of flood happen again next year and the year after that and the year after that. We could also have it happen not once again for the next 100 years. So it is very random in that sense. If you look at the statistics of the question and say, well, if you look back to the 100 or 80 years of record that we do have, this kind of flooding event doesn't happen very often. It might happen maybe every 50 years or so. And so it doesn't mean that we've had two, we're good, we've done our flood quota for the next century. It just means that on any given year, you might have a 1, 2, maybe 3% chance of something like this happening. So the odds aren't very high, but if you look at the next 30 years, for example, then those odds that it happens at least once will certainly increase quite a bit. And so you might see this again. So unfortunately, it's not necessarily a question of if it will happen again, it is a question of when. And that might be a few years from now, it might be 100 years from now, nobody can really know. And unfortunately, with climate change as well, we do expect this kind of event to become gradually more and more frequent. But again, it's still up to chance. We could not see an event like this again for the next 100 years, or we could see it 10 times in the next 20 years. It really is, unfortunately, up to luck. And the fact that we had two bad events, one after the other, is certainly very unfortunate. So I think the last question that I have pre-prepared here was, please comment on the impact of clear cutting and the capabilities of MB forests and its impact on spring flooding as well. So that's a very, very tricky question because we do get that one a lot. And there's certainly some merits to the question. And I think the answer that I can provide, first of all, I want to give the caveat that I'm not a forester. And so I can't answer to a lot of that side of the questions and how forests are managed. I can't really answer a lot of those questions. And I can't answer the questions about, say, if you harvest a particular area of land, what the environmental consequences of that would be on the ecosystem or anything like that. But from a water perspective, if you harvest the land or you clear cut the land, after a few years, maybe 5 to 10, enough of the forest has grown back that from a water perspective, it's about equivalent to what it was before you cut it or you harvested it. And that's what a lot of the prevailing research does show. The other part of this question is, well, how much forest are we realistically cutting down or harvesting and per year? Knowing that it does eventually grow back, we just don't cut enough forest on a year-to-year basis to say that it has a significant impact on the St. John River Basin, because the St. John River Basin is so large. It is 55,000 square kilometers. So even if you clear cut or harvest a percentage of that, a small percentage, probably maybe less than 1% of that, it really is just a drop in the ocean, realistically, in terms of how much water is going to come down that river. And so one of the key points here is that it really does have to be managed well, and I think it is in our province. The side part to that, or the flip side of that, is if you have a small watershed that's just a few square kilometers and you clear cut half of it, of course it's going to have a very large impact on that small watershed. But we don't typically do that, and the St. John River is certainly not a small watershed. So all in all, if you look at the grand scheme of things and the big scale that is the St. John River, this kind of activity doesn't really have a whole lot of impact, at least not that I can see. And so that would be all of the questions I have pre-prepared. I see we have a few minutes left for other questions, so I'll hand it over to Brad if you want to read them out and I can answer, or maybe they're written down somewhere. But
Yeah, they're in the chat window, but I'll sort of take them in the order that they came.
sure.
You did a very good job answering the Keener's questions. Thank you very much for that. And there's a question, Jasmin, do you think a spillway in St. John would provide a permanent solution to extreme flooding at an economic cost?
So that's also a question that I can't give a whole lot of detail to at the moment. I can say that at the department, we have been working with the National Research Council of Canada, which is a federal organization that does this kind of work. And we've been working on modeling that particular scenario as to how that might look and what kind of impacts that might have. And we're nearing the end stages of that. And so I can't give any answers quite yet, but hopefully soon we'll be able to come out with a report or something that we can provide answers to that question.
Okay. Yes, so maybe you could stop sharing your screen there, and
Sure.
you would have a little bigger view of your image and my image. Yeah, that's great. And there's another question here. How will sea level rise affect the flooding scenario? As Mactaquac is head of tide, could flooding be even more severe from sea level rise?
That is also a very good question. And the answer is yes. It could even be more severe and will certainly increase the frequency of flooding events. It is part of the climate change equation, along with increased precipitation and increased flows that we would expect. But at the end of the day, when you look at the St. John River, it does all have to flow into the Bay of Fundy. And if in 80 years or so, the Bay of Fundy is on average 1 meter higher, it makes it that much more difficult for water to get out of the St. John River system and into the bay. And so we can certainly expect sea level rise to have an impact on flooding.
Okay, thank you very much. We have another question. Why are there no hydrometric water level monitors near the Mactaquac Dam?
There used to be one at McKinley, which is upstream of Fredericton and downstream of the Mactaquac Dam. The reason there is no more gauge there would be because the Mactaquac Dam keeps track of how much flow is going through their gates and their turbines and how much flow is coming into the head pond as well. And so there's no need for an Environment Canada gauge because we're fully aware of how much flow is coming through the dam. Because
Okay,
NB Power measures it.
very good. Another question. This is an interesting one. Is the snow water equivalent concept always reliable? How about the amount of snow that sublimates? And is sublimation an important process too in terms of snow budget loss?
So sublimation is certainly a part of the equation. And so when we talk about snow water equivalent, we are physically measuring how much is on the ground. We go out and we take samples of how much is on the ground.
Right.
And so for us, when we say there's this much snow and snow water equivalent on the ground, that is in fact what is measured. So in terms of modeling and internal capacities like that, it does take that into account and to some extent. But the measurements are really what we rely on. And the measurements go and feed into our models as well for flood forecasting and flooding and hydrological cycle as well.
So the sublimation is accounted for, is what you're saying?
It is accounted for internally in the process.
Okay, and this is a general question along the lines of sea level rise, but is there any data that links the increase in flooding to climate change? So I guess the broader impact of...
I'm sorry, Brad, you kind of cut out there.
I'm sorry too. Okay, so is there any data linking increased flooding to climate change in general? So sea level rise is certainly one of the impacts. What about temperature and weather and climate change in general affecting the amount of snow and rain that falls?
So climate change is part of a very large trend where increased temperature and increased precipitation and increased sea level are all part of that trend. And so it's very difficult to say that the 2018 flood was caused by climate change, because it is a very large, it's a trend that you can say that events like 2018 flood and 2019 flood will become more common as time goes on. And there's evidence to suggest that. There's plenty of research to suggest all of these things, that increased temperature and increased rain would increase the flooding.
Mhm.
So, but there's no like hard analysis proof that would say, it's just with statistics, trends are very difficult. You need a lot of data to have trends and to see if the trend has changed over time. And we just don't have enough data yet to really say that it has had a very significant impact on flooding yet. It could just be the randomness of the situation, at least for flooding in general in New Brunswick.
Okay. Yeah. Let me see. I guess there's an interesting question. Can we have another presentation once the research is done on the effect of the spillway? You're looking question, but yeah, that's a good question.
Well, perhaps one day, but that is very much out of my hands. So
You said that NRCan was doing some research on that front. Is that correct?
it's a National Research Council of Canada. So it's not NRCan. It's a slightly different organization, but that mistake happens a lot.
Okay, very good. There's lots of comments. Thank you for the great, informative, professional presentation. Thanks, guys. Very informative. Are you seeing a significant divergence of the risk areas from now compared to 50 years ago? And risk areas, I suspect, would mean larger risk areas for today's flood mapping compared to 1972 and 73 flood mapping. If so,
Well,
are you attempting to identify the underlying causes of the difference? So I guess that's a question about previous flood mapping and the current flood mapping.
so if you look at the previous flood mapping that was done in the 70s, 80s, and 90s, there are several differences that have evolved from then, if you will. The first one would be the technology that is involved in flood mapping. The amount of computing power and modeling power and all of these things has significantly evolved from the 70s, 80s, and 90s. Computers in general are just so much more powerful, and you can do so much more with them. And so that's one reason why, if we were to put out flood maps today, you would see them as different than the ones that were created previously, just because the technology has changed and we are more capable and we understand the science a bit more. The other thing is we have the benefit of 30 to 40 years of extra observations. So when you look at an event or a flood map that was done, say, in 1970, then, or 1975 even, you wouldn't have the benefit of having observed the 2008 flood, the 2018 flood, and the 2019 flood. So you learn so much from those, and it also, it adds data to your repertoire of, well, this is what can happen and this is what has happened. So you know a little bit better what you can expect in the future when your period of record is longer. And of course, there's trends like climate change that are starting to impact these things as well. And so there are multiple factors that would go into this, why flood mapping would be different.
The essence of the question, is there a divergence of risk areas? In other words, are the risk areas different now compared to 70s and 80s? Is that what the models are telling us?
I would say yes. Generally, they would be different. I don't know how different. It'd be different in different areas of the province as well, but certainly they would be different.
Well, let me see. We're out of time. I think the limit was 8 p.m. and we're actually about 5 minutes after. So
Sure.
I guess we're going to have to call it the end of this webinar. This webinar will be recorded, as I indicated at the beginning, and posted on our YouTube channel. Everyone who registered for this webinar will get a link to that recorded video, assuming NBDELG is okay with us posting it there. We have to have our due diligence on our side as well. And I want to thank Jasmin for an excellent presentation, and to all the team in NB Riverwatch and NBDELG, especially the Hydrological Analysis Center there. I wish you all the best in improving your models and predicting let's say 6-7 days out, what can happen in the future. It's
Yeah, well,
very, very helpful for everybody living in this flood zone to have those predictions and be able to plan in advance.
well, absolutely. I think the main driver, unfortunately, is day-to-day weather, and if we can get better at predicting the weather, then we'll be better at predicting floods. So
yes, okay.
that's unfortunately how that goes.
A lot of interactions there. Again, thank you very much, Jasmin. It was a very good presentation, evidence-based, excellent. Thanks again.
Well,
And thank
you're
you
welcome.
everybody who attended for your questions, comments, and observations. And hopefully we will see you again in another webinar.
All right then.
Hopefully we'll be able to watch this video when it's posted on our YouTube channel, assuming it is. All right. Thanks again. Good night, everybody. Bye, Jasmin.
Thank you.